Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, today in this video, we are going to troubleshoot routing problems. So this is my topology in front of you on the screen. As you can see, in my topology, there are 5 routers. Router 1, router 2, router 3, router 4, and router 5. And guys, we are running OSPF routing protocol here. OSPF is enabled on all the devices, on all the routers, and this is OSPF multi-area topology because we have area 0, area 1 as well as area 2. After configuring OSPF on all the devices, there is some issue, and because of that issue, user from this 50.1.1.0/24 network are not able to communicate with user of these network as well as user of this network. Getting my point? So that means there is no end-to-end reachability between 50 and 10's network, guys, as well as between 50 and 20 networks. There is no reachability. Users are not able to communicate. Like you can assume there is one user right behind router number 5 whose IP address is 50.1.1.1, and there is one user behind router number 1 whose IP address is, let's say, 10.1.1.1. So 10.1.1.1 is not able to communicate with 50.1.1.1. Or let's say there is one user behind router number 2 whose IP address is 20.1.1.1. So 20.1.1.1 is not able to ping 50.1.1.1. So this is the problem. Here also you can read the problem, guys. Problem is what? Customer is complaining here. This is customer is complaining that users from 50.1.1.0/24 network are not able to communicate with any users of 10's and 20's network. Getting my point? So there is no reachability, and as a network engineer, you need to verify the problem, you need to find the issue, and then you need to troubleshoot it. So our end task is there should be end-to-end reachability between these all networks. Getting my point? Okay. So always keep in mind one thing, guys. Whenever you are troubleshooting routing issues, first of all, you should start verifying from routing table. First of all, you should check routing table of each routers. Like in this scenario, as you know, if 10.1.1.1 want to communicate with 50.1.1.1, so first requirement is what? 50 network, like 50.1.1.0/24 network should be there in the routing table of R1, right? 50 network should be there in the routing table of R1. In the same way, 10 network should be there in the routing table of R5, right? So we will verify the routing table of R1 as well as R5. Okay. After that, router number 3 and router number 4, both router should have both network, like 10 network as well as 50 network in their routing table. Okay, so you need to verify the routing table of these router as well. But first of all, you are going to verify R1 routing table, then R5 routing table. If route is there, right, and then ping is not working, then my troubleshooting step is going to be different, right? If route is not available, then we are going to find why route is not there. We are going to verify OSPF neighborship. We are going to verify, filtering, route filtering, because maybe because of route filtering, R5 is filtering 10 network or R1 is filtering 50 network. Okay, so there are many more possibilities. So guys, without wasting our time, let's begin. First of all, I am going to verify the routing table of R1. So let me take you to R1. Here you can see, to verify the routing protocol, that which routing protocol we are running over here, you can run command show IP protocol. This command will tell you which routing protocol you are running. So you can see, guys, routing protocol is OSPF process 1, OSPF process ID 1. Okay, then to check routing table, what command I can run? Show IP route. But in real time, if you will run through IP route command, you will have thousands of prefixes in routing table, right? We will have lots of prefixes under routing table. So we need to filter the output. Okay, so here we are troubleshooting the routing problem, right? And we are verifying the routing table of R1 for 50 prefixes. That 50 prefixes is available in the routing table of router 1 or not. So what we can do, we can say show IP route for 50 network, 50.1.1.0, And yes, you can see guys, this network is in the routing table of R1, right? And this network is reachable via 13.1.1.3. This is next hop IP address. This is IP address of router number 3. And this next hop should be reachable. Okay, so we can verify this also, that next hop is reachable or not. Ping 13.1.1.1. Yes, you can see ping success rate is 100%. That means I am able to ping next hop IP address. Okay, so if 50 network is there in the routing table of R1, R1 can forward traffic for 50 network to 13.1.1.1. We don't have problem till now on router number 1. In the same way guys, I am going to verify routing table of R5, router 5, because router 5 should have route for 10 network for 10.1.1.0. So let me run show IP route 10.1.1.0. But you can see here network not in table, so this network is not available in the routing table of R5. So this is problem. Why this network is not available? We will verify it guys, don't worry. But before that, let me check other networks like 10.1.2.0. so IP route and 10.1.2.0. so you can see this network is also not available. 10.1.3.0, 3.0. Yes, this network is also not available. 20.1.1.0, 20.1.1.0. Yes, this network is also not in table. 20.1.2.0. Yes, not in table. And this network 3.0. Okay, so router 5 don't have route for any 10 prefixes as well as 20 prefixes. Now question is why? So what you are going to verify here? First, routing protocol. The routing protocol is working fine or not, right? So what command I will run? Show IP protocol. And here you can see routing protocol is running, that is OSPF process ID 1. That is fine. And guys, in front of you, you can see there is filtering as well, right? Incoming update filter list for all interfaces is 10. That means we are running, we have configured access control list number 10 over here, and we have applied that access control list under OSPF in which direction? In direction, right? For incoming updates. So let me verify the access list also over here. Apart from it, router ID is 5.5.5. Rest configurations look like fine, right? Okay, so IP access list. So you can see under this access control list, we are allowing only 10.1.0.0 with /16. That means these all 10 prefixes will come under this entry guys, right? All prefixes are matching. And then we are allowing this network 20 network 20.1.1.0. so on router number 5, this is router number 5, I need to verify, you know, R4 routing table. It means OSPF on router number 4 also. So on router number 5, you can see we are allowing only these prefixes as well as these prefixes. So this access control list look like fine, right? We are just filtering unwanted prefixes over here, like prefix between router 1 and router 2, network between router 2 and router 3, network between router 3 and router 4. So these are unwanted prefixes, right? We don't want to install these prefixes under the routing table of router 5, right? So that's why we have filtered it. Okay, so this configuration is fine, we don't have any problem. Now on router number 5, we can verify the OSPF neighborship as well, like show IP OSPF neighbor. So you can see there is one neighbor, that is router number 4 guys. Okay, so this is fine. I think router 5 configuration is okay till now, right? We don't have any problem. Only issue is router 5 don't have any 10 prefixes as well as 20 prefixes. So guys, if there is neighborship between router 4 and router 5, and router 5 don't have 10 and 20 prefixes, that means router 4 is not advertising to router number 5, right? So let me take you to router 4. On R4, here also I am going to check show IP protocol first, that which routing protocol we are running. Routing protocol is OSPF 1, that is fine. Here also we have filtering in incoming direction, right? We have one filtering for all incoming updates. We can verify it. So IP access list. So here on router number 4, you can see we are allowing all 10 prefixes, all 20 prefixes, as well as 50 prefix. Okay, so this access control list is also look like fine. It is not going to impact any and networks. Okay, networks which are running on router number 1, 2 and 5. Okay, apart from it, here on router number 4, so IP OSPF neighbor. So IP OSPF neighbor. Let me verify the OSPF neighborship here. And you can see guys, router 4 have OSPF neighborship with router 3 as well as with router number 5. Okay, but as you know, router 4 is not your ABR router, because router 4 is connecting area 1 and area 2. So in this scenario, we need to extend area 0. We need to create one virtual link between router 1 and router 4, and there should be one neighborship between router 1 and router 4. So if you will extend area 0 over area 1, then router 4 will become ABR router. ABR router, and then it is going to advertise 10 prefixes in area 2. So if you don't know OSPF virtual link concepts, guys, please watch my previous video, means yesterday videos. In yesterday videos we talked about OSPF virtual link in detail. Okay, so here there should be one OSPF neighborship between router 1 and router 4 that we are not able to see. Why? What can be the reason? What we need to verify over here? We need to verify the OSPF virtual link configuration, that OSPF virtual link is configured on router number 4 or not. So what we can do, simply I can run command show IP OSPF virtual link, guys, and you can see OSPF virtual link is already configured over here. Virtual link OSPF underscore VL1 to router 1.1.1 is up. So this virtual link is up, and there should be one more virtual link here. You can see virtual link OSPF underscore VL0 to router 2.2.2 is up, right? So virtual link configuration is also fine on router number 4. Then if there is no neighborship and OSPF virtual link is already configured on router number 1, we should verify what? We should verify virtual link configuration on router number 1 as well as on router number 2. The router 1 and router 2, on router 1 and 2, virtual link is configured or not. So let me take you to R1, guys. On router number 1, let me check so IP OSPF virtual link. So here also you can see OSPF virtual link is already configured, right? Virtual link OSPF underscore VL0 to router 4.4.4 is up. Okay, then let me take you to R2. So IP OSPF virtual link. Here also OSPF virtual link configuration is fine, right? OSPF virtual link is already configured. Then why we don't have neighborship between router 1 and 4 as well as between router 2 and 4? Okay, so what we can do one thing. We can check all the commands under OSPF on router number 1, router number 2 and on router number 4, because I think there is some misconfiguration, guys. Okay, so let me do one thing. On router number 1, I am going to check all the commands under router OSPF. Simply I can run this command, so run, and then section router OSPF. Show me all the commands under router OSPF. So you can see this is the first command, OSPF router ID 1.1.1.1. Then guys, area 0 authentication. Okay, so we have configured authentication as well in this scenario. Then area 1 virtual link 4.4.4, this is correct. Authentication key is Cisco, fine. And then we have one distribute list in indirection. Let me check. So IP access list. So yes, you can see we are allowing 20 prefixes as well as 50 prefix. Access list is fine here, right? So authentication is configured, virtual link configuration is correct. On router number 2 also, so run and then say section router OSPF. Okay, here also you can see OSPF virtual link configuration is correct. Authentication key is same as Cisco. Okay, guys, on router number 1, I want to check entire OSPF routing table. So IP route OSPF. So you can see this router R1 is learning these all prefixes, like 20 prefixes as well as 50 prefix. Who is advertising this 50 prefix if we don't have neighborship between router 1 and router 4? So let me do one thing. on router number 3, so IP, or on router number 1 as well, we can check database directly. So IP OSPF database, like just I want to check who is advertising 50 prefix to router number 1, so IP OSPF database. So here we should have 50 prefix. Yes, 50 prefix 50.1.1.0/24. Who is advertising 4.4.4.4? Oh my god. So IP OSPF neighbor. So only router 3 is neighbor. There is no neighborship between router 1 and router 4, but router 4 is advertising this prefix in the form of which LSA, guys? In the form of LSA 3. That means router 4 is acting as ABR router, right? So can I ask to router number 5, who is your ABR router? So IP OSPF border router. Yes, you can see router 4 is already acting as ABR router. That means virtual link is configured, right? But guys, neighborship is down. Virtual link is configured, but neighborship is down. Okay, so now problem is cleared, because router 4 is acting as ABR router, right? Even router 4 is advertising area 2 prefixes in area 1, right? In the form of LSA 3. Here you can see on router number 1, 50 prefix in the form of LSA 3, right? Advertising router ID is 4.4.4, right? But so IP OSPF neighbor. So IP OSPF neighbor. We don't have neighborship. Guys, if you have scenario like this, that means there is some problem with OSPF neighborship. And if there is some problem with OSPF neighborship, it can be because of, authentication, it can be because of route filtering, it can be because of misconfiguration, right? So let me do one thing on router number 1. Let me check. So IP OSPF interface brief. Let me run this command as well. So you can see OSPF is enabled on virtual link, right? VL0. On router number 2, so IP OSPF interface brief. Here also OSPF is enabled on virtual link. Then guys, let me take you to R4, and here so IP OSPF interface brief. So yes, OSPF is enabled on virtual link, right? And network type is point to point on router number 4. On router number 1 also network type is point to point, and on router number 2 also network type is what? Point to point. So if everything is fine, then why neighborship is down? Maybe because of authentication then, right? So let me verify the authentication again. So IP, so run, okay, so IP OSPF, and there is one command, virtual link. Let me say virtual link. So on virtual link, here we have plain text authentication, right? State point to point, hello. Okay, it is sending hello messages, no problem at all, right? Hello due time is, you can see, 5 seconds. Simple password authentication enabled. Then what is the problem here? On router number 4 also, let me check it is sending hello messages or not. So IP, or simply I can copy the command on router number 4. Yes, here also it is sending hello message, no problem at all. Okay, after every 5 seconds, so sorry, 10 seconds. Okay, then guys, let me verify the password once again. Password over here is on router number 1, so IP OSPF, so IP protocol. So IP protocol, will this command show me the password? This router is ABR, okay, that is correct. No, I can run this command, so run. Let me check the command directly. So IP, so run section router OSPF. So here you can see authentication key is what, guys? Cisco on router number 1 and on router number 4. So run section router OSPF. Here authentication key is also Cisco, but there is some misconfiguration. You can see first C is here a small, but on router number 1 first C is I think capital, right? So actually authentication key is mismatch in this scenario. You have one more option. You can debug IP OSPF hello. If it will show me the key, receive hello message, sending hello message. Okay, sending hello message. It's showing this only, and all and debug IP OSPF adjacent. Wait, it's showing like this only, no? So this is the problem, authentication key mismatch. So what we can do in this scenario, simply I can run one command on router number 1, like I can remove authentication from router 1 for now, router OSPF 1, or I can say area 0 authentication. I'm going to remove this command, and now I am expecting OSPF neighborship between router 1 and router 4. Just wait for a minute. So IP OSPF neighbor, and on router number 4 also I have to remove this command if I am running. So run yes area 0 authenticate. Let me remove this command from here as well. Config T, say router OSPF 1 and no area 0 authenticate authentication. So IP OSPF neighbor, still we don't have neighborship. Just wait for 10 seconds. Let me clear IP OSPF process once. Yes, neighborship with 3.3.3. so IP OSPF neighbor. So run section OSPF. Now it should work because we have disabled the authentication. Let me remove this command as well from the virtual link. Say router OSPF 1 and no to this command, guys, here, and then on router number 4 also router OSPF 1, say no area 1 virtual link 1.1.1 authentication key is Cisco in a small. So IP OSPF neighbor, still we don't have neighborship. Okay, then what next? We have removed the authentication as well, but still we don't have neighborship. So IP OSPF neighbor, right? So IP OSPF. So this is clear that problem is with virtual link only, right? So virtual link is up over here. Virtual link is up. I think you know what is the problem here. This router is not able to forward hello message to 4.4.4. So IP route OSPF because of route filtering. So let me do one thing. For a moment I'm going to remove the distribute list configuration from OSPF. So simply config T router OSPF 1 and say no distribute list number 10 direction in, because just I am verifying the issue, right? Do so history. I'm going to copy this command and will put on all the router. So this is the command. Okay, go to router number 2, leave router number 2, directly to router number 3 and router number 4. Now so IP route OSPF, yes, now it is receiving unwanted prefixes as well. And now you can see guys, we have new neighborship, right? So IP OSPF neighbor, right? Actually router 1 was not able to send hello message to router number 4, right? Because of that neighborship was not coming up. Now we have neighborship here, fine. On router number 2 also I'm going to remove the authentication router OSPF 1 and will apply the authentication again, right, with correct with same key router OSPF 1 and do so run section OSPF. Let me remove few commands from here, like this command, say no to this, and guys then no to this, no to this, and no distribute list, no distribute list 10 direction in. I'm going to remove this command also for a moment and we'll apply it later. So IP OSPF neighbor, here also now we have neighborship as you can see. And now let me verify the routing table of R5. This time I am expecting R5 should have route for 10 network and 20 network. So IP route 10.1. So IP route 10.1.1.0. Yes, you can see this time this network is in the table, right, reachable via 45.1.1.4. but so IP route OSPF, this time you can see guys, we have all 10 prefixes and all 20 prefixes. Let me verify the connectivity. Ping 10.1.1.1 and source 50.1.1.1, and this time you can see ping is working. In the same way we can ping to 20.1.1.1 as well. Yes, ping is working, right? Now guys, everything is fine. Now what we need to do, we need to apply the distribute list, because on router number 1 if you will check routing table, so IP route OSPF, you can see there are lots of unwanted prefixes, right, like 23, 34, 45. These are unwanted prefixes guys, right, and we want to filter it. So we have already access list here, so IP access list, we have already access list, right? Simply I'm going to configure distribute list here. So go to config T and then router OSPF number 1 and say distribute list number 10 direction in, right? Do so history, I'm going to copy the command, these two command, because I'm going to apply it on all routers. And now so IP route OSPF, you can see routing table is filtered. We have 20 prefixes as well as 50 prefixes. So let me apply this distribute list on all other routers as well, like on router number 2 as well as on router number 3 as well as on router number 4 and on router number 5. This command is already running, right? Now guys, next thing is we need to secure virtual link. So again we can configure the authentication with router number 1, router OSPF 1, say area 0 authentication, and then area 1 virtual link with 4.4.4.4 and configure authentication key, that is what Cisco. On router number 2 also I need to do same thing, router OSPF 1, area 0 authentication, area 1 virtual link, and whatever command were running there, right, previously I am applying same commands again, 4.4.4 authentication key, my god, 4.4 and authentication key is Cisco, right? Now again, so IP OSPF neighbor, you can see we have ST neighborship, right? because this is neighborship on virtual link, right? If you have any doubt guys, any confusion in virtual link concept, please watch my previous video. Router OSPF 1 and say here also command was area 0 authentication, then area 1 virtual link 1.1.1.1 and then authentication key was what Cisco. Okay, then we need to do same thing for router 2 as well, 2.2.2. okay, and now on router number 4, so IP route OSPF, you can see there is no unwanted prefixes. We have all 10 prefixes, we have all 20 prefixes as well as 50 prefixes, right? And now everything is fine. I'm going to write the configuration of all routers. Like on router number 1, let me save the configuration. On router number 2 also let me save the configuration. On router number 3 also let me save the configuration. On router number 4 save the configuration, and router 5 save the configuration. And now let me verify the connectivity. Ping 10.1.1.1 source 50.1.1.1. yes, ping is working fine. Ping 20.1.1.1 and source 50.1.1.1. see, ping is working. From router number 1 I can verify the connectivity between 10 network and 20 networks as well guys, like 20.1.1.1 and source 10.1.1.1. so this ping is also working fine. Okay, so we have verified the issue, we have find the problem, and then we have troubleshoot it. So guys, this was a small troubleshooting of OSPF. If you have learned anything from this video guys, don't forget to hit on like button. If you have any question, any concern, please let me know in the comment section. We will meet soon in next video. Till then, stay safe. Bye bye guys. That's all for today.